Okay, so these are bearings I pulled out of Mr. Hambini's BB86 bottom bracket I put into the Yolio. So you're wondering why I did that. I just put the bottom bracket in. I'll get around to that. But anyway, I pulled them out. I wanted to examine the product and see what I could learn just by looking at it. One of the things that apparently happens a lot is fake bearings. Ntn doesn't just manufacture their product in Japan. They manufacture products around the world, apparently. But in Asia, it's in Indonesia, China, Japan, and Thailand. India also, South Asia. But you can go to the Ntn website. What is that website? I've got it here. ntnglobal.com, and you're going to find this nice little map. This is not the home page, but you go to About Us at the home page, and it brings this up. You can find the global network, and they have Europe and Africa, Japan as a separate region, Asia and Oceania, and the Americas. Now look at that, Greenland is apparently part of Europe and Africa. So you can click on each one of these tabs and go right to that specific region. And then if you do that, you're going to get down to here where it says distributors. I'm sorry about my fat finger in the way. The offices is a different thing. The distributors, most of the time they have a direct connection with Ntn, but not always. However, if you're worried about getting a fake piece of equipment, there's a way to avoid that depending on where you live in the world, and apparently you can get this stuff anywhere you want. Okay, you click on distributors and then just click on location, and you pick a country where you live. If you're in Belgium, let's pick that. Up pops a bunch of distributors. Well, in Belgium's case, there's two. If you go to Thailand, there's more, and if you go to China, there's a lot. But you can find this for wherever you are. So here's China, for instance. You're probably not in China if you're watching this. And it'll tell you which one of these, they're official distributors. They're on the website. And look at that, there's 8 pages there. China, India, Indonesia, Ireland, anywhere on earth, just you'll find a distributor that sells the authentic stuff. Now, I looked up Ntn on the web in Thailand, and there is an Ntn Manufacturing Thailand. So not only are there distributors, but there's manufacturing all over the world. So I've read comments on the internet about SKF, which is another premium brand of bearing. FAG, NSK. People say, well, you got to be careful with SKF because it's not all made in Japan. Well, guess what? Ntn makes stuff all over the world. Now, if you look at this bearing, part of my examination, it tells you right on the seal, Japan, okay? It says on the seal, I don't know what, let me see if I can find it with my it's hard to read and the light is not great. Okay, right there. That's the bearing part number 6805LB. Now, LB indicates it's a single seal, non-contact seal. LB means it's a non-contact seal. What does that mean? That means the seal does not in any way seal directly to the inner race. It has a lip, however, that sits quite close adjacent to the inner race, but does not contact it. It's hooked into the outer ring. So that's a non-contact seal. And non-contact seals basically means less heat, less friction, possibly more ingress of water, dirt, and contaminants. But the main idea is to try to keep as much of that out without increasing the drag on the bearing, because the seals are the single biggest thing that causes bearing drag. Okay? Now these are made, non-contact seals are made specifically for that application where you want less heat, less friction, but also typically with bearings that have grease as a lubricant. So the seal is considered a hydraulic fitting because it's a weather seal, keeps water and crap out, but it also holds the lubricant in. So that's considered a hydraulic material, the lubricant. So it's a hydraulic fitting. 6805 is the part number. What's that mean? Well, you can watch Hambini's website, or you can just look it up. I watched his videos on this where he explains it in a PowerPoint demonstration. Maybe you're more astute than I am, but you're kind of paying attention to the overall presentation, and it's hard to grasp everything he says, but he does describe it exactly what it is. The 6 indicates what type of bearing it is. In this case, it's a deep groove radial bearing. Okay. The bearings run around inside in a groove that's cut into the inner and the outer ring. And when those rings are manufactured and put together, it forms kind of a U-shaped groove on the top and a U-shaped groove on the bottom that the bearings are contained within and run around in. So 6 just indicates the type of bearing. This is a deep groove bearing. 8 signifies a diameter series. And as far as I can figure out in my limited capacity, the diameter series has a corresponding width series. And so a 6.7 would be a narrower width, a 6.8 wider, a 6.9 even wider, like that. What's the 05? The 05 goes together. It's not two separate things. It's a singular code, 05, and that indicates the bore diameter. That's that open hole in the middle of the bearing. That's the bore. It signifies a bore diameter. If you look at the chart, which I've done, I've been studying this for the past couple days because I wanted to understand bearings more. If you look at the chart, what you're going to find is a list of bore diameters that correspond to a certain millimeter size. And I can't remember off the top of my head, but the first 3 or 4 of those code numbers, 0, 2, no, I don't know what it is. I can't remember, so I don't want to screw you up on that. But they're not a progressive size increase. It goes from like 10 millimeter bore size to 12 to 15 to 17. So there's no regularity there. However, once you get up to 05, so that must be 02, 03, 04, I'm not sure. When you get up to the 05 code number, it's a 25 millimeter bore diameter. And then from then on up to the end of the list on the chart, for every increase in number, there's a 5 millimeter increase in diameter. So 06 would be 30, 07 would be 35, on up, and it goes up on the chart to about 560 millimeters. So that's 56 centimeters. That's a good size bore diameter, isn't it? So that put me in mind of a story. One of the things I do on the side is I write silly stories. And I've been doing this ever since my kids were little children. I'd create fables and silly stuff and tell them stories. And I still do that, mainly just to entertain myself. But anyway, this whole thing about huge bore diameters got me thinking about a story. And I'm in the process of researching bearings recently. I went to a local SKF distributorship, and they've got a huge showroom. And right there in the showroom, right inside the door, ta-da, it's this big-ass fucking bearing with a huge bore diameter. And you go, well, I don't know what that fits on, but obviously it's a big-ass shaft for a big-ass piece of machinery. Mr. Hambini and Pete Torque and people smart like that had to go to college to learn all of this stuff, they'd be able to tell you in an instant what it fits on. But to me, it just made me wonder about how I would apply that, and that led to the silly story, which I'll be happy to tell, and you can skip over that, but that'll be a different video that I'll stitch together with this particular presentation. Anyway, it says 6805LB. Now, I was curious about that because the actual code that I ordered these from the Ntn distributor in Bangkok, you can see that right there, SSV Machinery. How to find that? Well, I called the manufacturing plant, which is not far from my house, and they said, we just make stuff, we don't sell it, but you can call this number. So I called that number, and they said, no, you need to call this number. So they put me in touch with SSV Machinery, and SSV Machinery is on the website here, so it's an certified dealership. Furthermore, they sent me in a text message, they sent me a photo of the NTN certificate that they have on display at their plant, their office. And they supply all kinds of stuff, machinery related stuff. And one of the things they supply is NTN. So that doesn't mean it's an NTN controlled entity. But if you're buying it from them, you can be pretty damn sure you're getting goods. So relevant to that point, avoiding fakes, go on the NTN website, or if you want SKF, go on the SKF website, whatever it is, and find the region that applies to you. Look for the distributors, it'll be right there, and then pick the one that's handy for you. So if all else fails, of course you can get it from Dr. Hambini. He sells his stuff. However, for me to get it from Hambini, it's extra money because I'd have to pay import duty fees and everything. I was expecting to pay about $30 for a set of bearings or more. And it wasn't that at all. When I asked them to quote me a cost, they quoted 320 Thai baht. Now that's under $10 for both. And then they added a couple bucks more for shipping it. And they put it in a box and shipped it to me. I got it 2 days later. So anyway, LB, that's a contact seal. That's what that indicates. But if you look on the list of code numbers, a 6805LB product part number indicates it's a single seal. Well, this is a double-sided seal. But both of the seal numbers say LB. But if you order this part you have to order 6805 LLB, and that'll get you a non-contact sealed bearing that has a seal on both sides, and that'll be the right size for a 24 millimeter axle, which is what I've got. So if you got a 30 millimeter axle, you got to look up the different part number, and I'm sure if you look on Hambini's website, there's that information. So that's the first thing I discovered, is the printed information that's right there on the contact seal, Ntn Japan. Okay, now that's where the company is headquartered and where it was founded. That doesn't mean that this was necessarily made in Japan. However, there's other information, and it's much harder to see. I don't even know that I can get a good view of that. Right on the upper ring, on the edge facing us, is some code numbers. There's a lot of information there. Right there, you can't see it well, but what it reads is Japan, and then it has a code number after that, and it looks for all the world to me, and I've looked at it with my magnifying glass and with my reading glasses on, it's still hard to see, but it looks like 15A-B, or it could be A-8, not sure. Further information right there, can't really see it, but I've looked at it closely, and what it says on this particular bearing is 200409. Now, if you ask me, that's a production date, and then right after that is another batch of code numbers and letters, and it looks like L344. So I would hazard a guess that this particular bearing was made way back in September of 2004. Now, I could be wrong, but that just seems like what that is. And the other little code number after that might be a lot number. Probably is. That's my guess. So I'm just trying to deduce stuff, not knowing anything. Take the information at hand, try to make sense of it. In any case, it does say Japan on that ring. Now, that could either mean, well, NTN is in Japan. Also, it does say right there, but you can't hardly see it on this particular one at all. It does say NTN. So if you're getting a fake, I doubt that all of this stuff is on that. It might look exactly like it, but I doubt that all of this information is on that outer ring. So you could take it out before you buy it if you're standing there at a place where you get it. I would never order these off the internet. You know, why would you do that? You're just multiplying your chances for disappointment. I don't want you to be disappointed. Don't do that. Go on the website, look up the damn manufacturer, and find a distributor near your home. Do it that way. But my guess is a fake is not going to have that level of detail. If it does, it's a damn fine fake. Some other things I learned about the bearings, and I'm going to take this apart and examine it. That will be a separate video attached to this. So it has all of this information on the seal, and also on this ring. You can't see it on this one, but on the other bearing, I was able to examine it closely enough, and I think right there, it actually reprints the code number for the bearing. It says 6805 there also. On the other side, on the ring, there's no information, just on the seal. So the question arises in my mind, is there a direction-specific way to mount these bearings in your bottom bracket cup? In other words, does the side that has no data on that outer ring go in? To me, if there is a direction specific, that's where it would go in, because if you had to look at the bearing on your bike, you'd want to see this data on this outer ring facing you so you can read it like this. If it's in, so I don't know if that's the case. If there is a direction specific, it doesn't look like it would be, but maybe you would want to mount it with this data facing out. However, that's a pertinent question for me, and I'll probably seek Hambini's knowledge to answer that. My guess is no, it's not direction specific. This is just, if you want to know what's in your bottom bracket without pulling it out, put the data facing the outside. However, it's pertinent to me because my local bike shop is part of my effort to figure out what to do to rectify the initial faulty install I made of the Hambini bottom bracket. I took it there, and I don't know why they did that, because they have a proper and a really good bearing pulling device. But he just took one of those things that you put inside and knocked it out. I didn't think anything of it at the time because I didn't know any better. But then, as part of my research, I was watching some old Hambini videos where he's talking about bottom bracket eccentricities and misalignment issues, and why press fit is better than thread fit for that sort of thing. He said, really, in no uncertain terms, don't do that. Don't knock them out. And if you do, don't reinstall them. Because he then went on to explain in a very patient, professional manner to me, George, it causes what's called brenneling. Brenneling is a technical term, but you can look it up. Basically what it means, it's going to pit the races, the interior races that are the groove that the bearings run around in. And then it's going to be notchy and shit, and it's going to wear out prematurely. Well, okay, too late. I didn't know any different, so I couldn't get the bottom bracket in, even using my local bike shop super duper $600 or whatever it is. $600 I think it costs for the top of the line Park Toolkit bearing installation and removal tool. Couldn't get it in. That's when I knew, well, it's not going in, it's got to come out. So that's an old story. It's previously documented in a video on my YouTube site. But I didn't know that putting the knocked out bearings back in would have any real major effect. I realize that's an unkind way to do it, and there's better ways, but and this gets into why I took the bearings out, because I had further damage to the bearings after I rode for about 500K. I came home from a long ride, and honestly, I couldn't feel a damn thing. So that's why when people are talking about they'd put ceramic bearings in their bottom bracket, and boy, I feel really fast and spin like, silk. Man, I'm skeptical of that, because now I'm not an insensitive person. I rode about 45K on that particular ride with the Hambini bottom bracket, and it was one of many, totaling over 500K probably in a week or so, 2 weeks, 3 weeks, I don't know. And it felt just fine. In fact, I was marveling to myself, man, I love the feeling of pedaling this bike. Now, granted, I was pedaling on the way to a really nice restaurant along the coast road in the evening, not so much traffic. It was sweet. The next day, I dropped my chain because I wanted to re-wax it, and I noticed, well, hell, the cranks aren't turning very well. What's going on? Check the brakes. No, they're not pinched tight or anything. The cranks were just bound. you could spin them, but it took effort. Now, I didn't notice a thing. So I disassembled the whole damn thing and took the bike back up to my local shop, and I said, do you have a proper bearing puller? Oh, yeah. Well, let's use that and pull these bearings out. So we pulled the bearings out. Lo and behold, this is the drive side bearing. It spins, but when I took the cranks out and the axle, I was just spinning this around with my finger. It felt notchy. Well, that was actually when the axle was still in, but the cranks were off. This one here, guess what? It's completely seized. Doesn't spin at all. So here's a curious thing. Look at the markings on the outside. Look at that crap. Now this is after about 500K. Now that's not dirt. It won't come off. And it's only on one side. Now the other thing that's of interest is if you look inside there, now I don't know if I can get a good view of this. This light may not be helping at all, actually. And it's hard to see, but I'll describe it for you. It's dark. The inner ring is dark. Now that's not dirt, it's just darkened. Now that's where what I call the top cap, it's actually a sleeve that fits from the outside, covers the seal and the bearing, and the sleeve goes into the inner bore. Now this thing is a 25 millimeter bore. That inner sleeve is a thin sleeve, and it's made to take up the difference between the race and the axle, which is 24 millimeters. That's how that works. So the inside of this race is discolored. Can't see it, I apologize. So why is that interesting? Well, looking at the drive side, non-drive side bearing, it's got similar stains on one side, not so much on the other. Now, on this side, this bearing was facing out. And this is the side that has the data on the outer ring. So these weren't put in the same way. One was put in with the data on the ring facing into the cup, and the other was put in with the data on the ring facing out of the cup. This is the one that's seized up, and the data's facing out of the cup. So I'm hazarding a guess that it doesn't make any damn difference which way you put it in. It's just, if you want to see the data, don't bury the data by putting it in. What's also different, this one, the race is completely polished. It looks immaculate, untouched, silver. The other one, the drive side, is black. Now this is the one that's seized up. So why is this looking like that? Well, it's been polished, obviously. The bearing seized up, but that Delrin sleeve was in there. And what do you think happened? I was riding around on that, and that Delrin sleeve is now basically functioning as my non-drive side bearing surface, because this is frozen up. It's not moving. But that Delrin cap would spin around inside this. It's not a super tight fit. So the axle is spinning around, and the load is completely on the sleeve, and the sleeve is acting as a bearing. It still worked, ladies and gentlemen. It still worked, and yours truly couldn't tell a damn bit of difference on a 45K ride. It felt good. So you can tell me all day long that, boy, those bearings, those ceramic bearings I put in there, it spins like silk. I can really feel the difference. I think you have to be imagining stuff largely to really feel the difference. Now, there might be people that do feel the difference, like riders that live on their bike, that ride in pro pelotons. Those guys live on their bike. Furthermore, they're not going to run around with bearings with contact seals. They might not even have seals on the bearing. They might not put grease in the bearing. You know, they might just have the mechanic fill this up with oil. And of course, that's going to wear out. But for a certain type of ride, like, I don't know, under 50K, probably might work okay and spin really good because it's a lower viscosity by far. So anyway, that's what I've been able to determine just by examining this. And I haven't even picked the seals off to see if there's anything I can see on the inside. Obviously, there's going to be some damage on this non-drive side. This one is notchy. That's probably because, well, I didn't treat them very kind when I was trying to put that bottom bracket in the first time. There's no doubt about that. And I'm not here to shovel the blame on somebody else, but it probably didn't help to knock them out with that tool. As Mr. Hambini explained, it's going to pit inside. And he was real emphatic in this. I don't know if it was a video, I was reading it on his website and his blog. Do not. That's an absolute no-go. Do not. If you knock them out, don't put them back in. They're done. Get new bearings. And I'll tell you what, according to Dr. H, Ntn is about as good as it gets. Now, he's actually done tests and measurements. He's not just saying so. He puts them in his bottom brackets for a reason. He's tested them. He prefers Ntn. Now, granted, he'll say they all are good. SKF is good. FAG is good. NSK is good. Real good. Those are the ones you want to get. But if you have an option, get an Ntn. Now, for some reason, he says it's difficult to get Ntn because they don't sell to end users. And that may well be the case somewhere, but man, I tell you what, here in Thailand, Thai people are all about selling you whatever they have to sell you. And there was no questions asked when I called SSV machinery. Now, you can't get it from the manufacturing plant for an obvious reason. They're not into doing retail sales. They're into making shit. And they're busy doing it. There's huge industrial parks near where I live filled with hundreds of factories making all kinds of stuff. So all these factories need bearings, and they need bigger bearings than this. So where was this bearing manufactured? I'm hazarding to guess it's manufactured in Japan. But I'm interested. Oh yeah, I forgot to tell you. I'm going to use this word in its original meaning. I'm sorry, I don't mean it in any sort of homophobic way. I find it queer that people do these unboxing videos. Now, I did one, but I'll tell you why I did it. Because Yolio said, George, if you do an unboxing video, we'll give you an 8% discount on your next buy. I said, well, why not? People do that. People like it. That video's had a lot of views. And it could be helpful to somebody planning to buy an R11 Yolio frame. But I don't know if anybody's done an Ntn bearing unboxing. So I'm going to do that. That'll be a separate video attached to this. I'm going to take those apart, examine it. I'll show you what I find. And I'm going to take these out. And what I'm going to be interested to see is if all of the markings on the seal and on the outer ring surface say the same stuff. Maybe it says Japan, maybe it says Thailand. I don't know. Now, this gets me back to a comment made by a young viewer who wrote me about quality control issues in Chinese factories. And I went over all of that in depth on a previous post. So I'm not going to get too deep on that. But how does Ntn control quality of a product made in Thailand? Well, you can guarantee that they've got people here doing inspections, and It's probably righteous. It's an NTN factory. It's not a Thai factory making it for NTN. It's an NTN manufacturing plant. So you can guarantee that if you buy it here in Thailand, you're getting the authentic goods made to the same tolerances. Speaking of tolerances, I went on an NTN table. Now, I wanted to learn what makes one bearing different than another. And so there's these tolerance tables that people like Peak Torque and Hambini, they don't even know all the shit in these tolerance tables. Why should they? If you open the tables, this is just introductory information informing you about the fundamental, 3 aspects of, here it says right there, bearing tolerances refer to 3 aspects of accuracy: external dimensional accuracy, machining accuracy, and running accuracy. And then it gives you an explanation that even a stupid cook, which I am, can understand. Now I have a fairly good grasp and also understand what bearing code numbers, part numbers mean. But I then went and I opened the tolerance tables. Now these are in-depth tables with a lot of different information. There's a lot of Greek symbols and numbers, and somebody like Dr. H or Peak Torque, they're going to look at that and know what they're looking at because they've studied it. They have to know what it means. But do they know what all of the tolerances are for every damn bearing application? Hell no. That's why they have tables, so people can look it up. Not even, well, there may be some Rain Man dude out there that memorized the whole tolerance tables, because human beings do some amazingly crazy and interesting things. But you can go to NTN or SKF and you can look up the same information. It'll teach you the basic stuff you need to know if you want to learn about bearings. YouTube is a wonderful resource, and Hambini is offering all that free knowledge that he worked hard to get. He's offering it for nothing. You should all pay attention to guys like when Peak Torque and Hambini talk. They went to a school and devoted, 4% of their entire incarnation duration here on Earth this time around. 4% right there to study engineering. It took them probably 4 years, I'm gathering, to get their degrees, and years of practice afterwards to enhance their understanding of what they're telling us about for free. Thank you very much to both of those guys and to all the people that teach us for nothing, for free on the web.